Solving absolute value inequalities. You guys somewhat remember talking about absolute value equations? Yeah, okay. Let's kind of talk about them a little more, just to kind of get a refresher. If I had the absolute value of x plus 6 equals 3, if I had an absolute value equation, what was the very, very first thing I needed to check?
The C if it's negative or positive.
Not yet.
To see if the absolute value is positive.
Very good. I needed to make sure my absolute value was completely by itself. Nothing being added to it on the outside, subtracted from it on the outside, or multiplied by it, or divided by it on the outside. Does that make sense? Is that the case for this little example? Yeah. The absolute value is completely by itself. There's nothing outside of it, is there? Now, after my absolute value is by itself, what did I need to check?
To see if it's positive.
The C value. I got to see if my C value is greater than or equal to 0 or less than 0. If it's greater than or equal to 0, I can set up my two equations. If it's less than 0, it's automatically no solution because the absolute value cannot equal a negative. Does that make sense? Is my C value greater than or equal to 0 or less than 0? Greater than or equal to. So let's set up our two equations. What was my first one?
X plus 6 equals 3.
Yeah, exactly the same as my original problem without the absolute value bars. Everyone remember that? Okay. What would my second equation look like?
X plus 6 equals negative 3.
Very good. Exactly the same, making my C value negative. Everyone recalling that? And then I would just solve these to get my two solutions. Subtract 6. X equals negative 3. Subtract 6. X equals negative 9. What did I have to do when I got my solutions? Not graph them. Check them, because when we had absolute value equations, we would sometimes have extraneous solutions, right? So if I plug both of these in, these both do check out. So these are my two answers. Everyone recalls all of that. Okay? Some of it, do we recall at least? Hopefully. Our absolute value inequalities will be very similar to our equations. That's why I wanted to do an example with you before we get into it. Are there any questions about it before we dive into it? All right, let's do it. So to solve the absolute value of ax plus b is less than c, for c is greater than 0. Does that say greater than or equal to? No. It just says greater than, right? So my c value must be greater than 0 in order for me to set up my two inequalities. Okay? It's very important. So to solve an absolute value inequality of this form, we want to solve the compound inequality. Ax plus b is greater than negative c, and ax plus b is less than c. So when we create our two inequalities, we're actually going to make one compound inequality. Does that make sense? So, very similarly, to solve absolute value of ax plus b is greater than c, once again, c still needs to be greater than 0. What values are greater than 0? Positive numbers, right? So my c value needs to be positive. Solve the compound inequality. Ax plus b is less than negative c, or ax plus b is greater than c. In the inequalities above, you can replace less than with less than or equal to. It's going to work the same way. And greater than with greater than or equal to. That's going to work the same way as well. Everyone got it? So, very similarly to our absolute value equations, our first inequality will be exactly the same without the bars. I don't know why they listed it second. I would have put it first, but it does not matter which place we put it. Okay? First one will be exactly the same without the bars, just like with our equations. Everyone got it? Second one, still making our c value negative. What else did we do on our second one? Flip the inequality symbol, right? Because now we're dealing with a negative c. So first one exactly the same without the bars. Second one, make the c value negative and flip your inequality symbol. Everyone got it? Same thing for this bottom one. Exactly the same without the bars for the first one. Second one, make c value negative, flip your inequality symbol. Everyone got it? The hard part is determining if it's and or. Okay? If it's less than, it's going to be and. If it's greater than, it's going to be or. And I want everyone to write this at the top of your paper, the word goal. But notice I am writing it a very specific way. I made a greater than symbol out of my G. I made a less than symbol out of my L. Everyone write it on your paper just like that. You're going to write this at the top of each of your assignments that are like this. You're going to write it at the top of your test so you can know when it's and or. Okay, this is greater than, correct?
Yeah.
Is greater than next to the O or the A? O, so it's going to be or. Does everyone see how that worked? Okay, here's less than. Is less than next to the A or the O? A, if it starts off as less than, it's going to be and. Everyone got it? Like I said, you're going to write goal at the top of your assignment, top of tomorrow's assignment, at the top of your test next week. That way you know if it's going to be and or it's going to be or. Okay? Any questions on this before we jump into our examples? All right. Solve each inequality. Graph each solution if possible. So what do you think the very, very, very first thing I need to do or check is? Yes? Very good. I've got to check and make sure my absolute value is completely by itself. Is that the case for letter A? Yeah. My absolute value is completely by itself. Check. What do I need to check next? The C value. In order to set up my two inequalities, what do I need to happen with my C value? It's got to be positive. It's got to be greater than 0. What is my C value here? Positive 2. Is that greater than 0? Yes, it is. So now I can set up my two inequalities. What does my first inequality look like?
X plus 7 is less than or equal to 2.
Very good. Exactly the same without the bars. X plus 7 is less than or equal to 2. Questions on that? First inequality is always the same without the bars. What's my second inequality going to look like? Can someone raise your hand and tell me? Right here.
Minus 2 on both sides.
My second inequality, what's it going to look like? I'm not solving this one yet.
Okay. 8x minus 11.
Nope. We're not on letter B. Yes.
It would be x plus 7, greater. Wait, will we flip the sign? Greater than or less than negative 2.
Very good. It's exactly the same as my first one. I make my C value negative and I flip my inequality symbol. Everyone okay getting those two inequalities? Any questions how I got those? Okay, I'm going to write goal at the top of my screen here. Does it start off as a less than or greater than symbol? Less than. So I find less than in goal. Is less than next to the O or the A? A, so is it and or or? And. Questions how I got that? Does everyone see how we used goal to determine if it's and or or? Okay. Once I get it set up, this just turns into a problem that we've handled the past 3 days, solving a compound inequality. Okay? So let's solve these two individually, keeping the word and between them, and then we'll graph it. What's my first step on both of these to get x by itself? Yep, subtract 7 from both sides. 2 minus 7 gives me negative 5. Symbol, flip or stay? Stay. I still need to flip my inequality symbol if I multiply or divide both sides by a negative. Bring the word and down. Negative 2 minus 7. Negative 9. Symbol, flip or stay? Stay. Is x now by itself on both inequalities? Yep, so here's my answer. Questions how we got that? So now I need to graph it. Open or closed circle on negative 5? Closed. Open or closed circle on negative 9? Closed. It's an and compound inequality. So I want the intersection, the overlap of the two graphs. I want where the two shaded areas are the same, correct? So x is greater than or equal to negative 9. Is that to the left or right of negative 9? Right. X is less than or equal to negative 5. Is that left or right of negative 5? Left. So where are my shaded regions going to be the same? What? Very good. Between my two circles. And there's my graph, and I'm done with the problem. Any questions on that? How do I feel about that so far? It's a little bit of a process, but once you get the process down, it's not too bad. Okay? Questions on letter A? Okay, letter B. Absolute value of 8x minus 11 is less than 0. Absolute value of 8x minus 11 is less than 0. Is my absolute value by itself? Yes, it is. Now I need to check my C value. Is my C value greater than 0? It is? No? 0 is not greater than 0, is it? No. So can I set up my two inequalities here? No. So if my C value is not greater than 0, I need to look at the statement that it's saying and determine if it's no solution or all real numbers. Okay? It's saying that my absolute value is less than 0. Okay? Any number I plug in to my absolute value, what's it going to spit out? A positive number, right? It'll either give me 0 or some positive number, right? Will 0 or a positive number ever be less than 0? No. So what do you think the answer is here? No solution. There's no number that will make this absolute value inequality true. Does everyone understand why? Once again, that absolute value will always spit out a 0 or some positive number because of the absolute value. 0 and any positive number will never be less than 0, so it's no solution. And that's all I have to do on letter B.
Now, if it was greater, then it would be real numbers, right?
It would be all real numbers except for the value that makes it equal to 0. Because it wouldn't be or equal to, would it? Does that make sense? Okay. Questions on letter B? We good with that? Can we do 3 more examples and then I'll be done?
Yes.
Okay. 3 more. Absolute value of x plus 3 is greater than 8. Absolute value of x plus 3 is greater than 8. Got to check 2 things before we do anything else, right? Is my absolute value by itself?
Yeah.
Yes, it is. Check. Is my C value greater than 0?
Yes.
Yes, it is. So I can move on to creating my two inequalities, determining if it's and or, and then solving them. So, since I can set up my two inequalities, raise your hand if you can give me my first inequality. Yes. Yeah.
On number 4.
Yep.
So basically, you would take down the bars.
Yep. So what do I get?
X plus 3 is greater than 8.
Very good. Exactly the same without the bars. X plus 3 is greater than 8. Questions on that? Very similar to our absolute value equations, right? Raise your hand if you can give me my second inequality here. Raise your hand. Yes.
Plus 3 is less than
Very good. X plus 3 is less than negative 8. Exactly the same. I make my C value negative and I flip my inequality symbol. We good with that? Make your C value negative, flip the inequality symbol. Raise your hand if you can tell me if it's an and or an or compound inequality. Or, how'd you get or?
Because the greater than.
Very good. It's greater than. So I find greater than on goal. Greater than is next to O, so I know it's or. Any confusion on how I set our problem up? We're all good setting it up. Like I said, once we get it set up, it's just like our past 3 days of assignments. We're solving a compound inequality now and graphing it. Okay? So on both of these inequalities, what's my first step to get x by itself? Subtract 3. I get x on the left. What's 8 minus 3? 5. Symbol flip or stay? Stay. Bring the word or down. Once again, I get x on the left. What's negative 8 minus 3? Negative 11. Symbol flip or stay? Stay. Are the x's now by themselves? Yes. So here's my solution to our absolute value inequality. Any number that is greater than 5 or any number that is less than negative 11 will make this inequality true. Okay? So let's graph it. There's my number line. Open or close dot on 5? Open. Open or close dot on negative 11? Open. This is an OR compound inequality. I want the union of the two graphs. I want the two graphs on the same number line. So if it's x is greater than 5, would I be shading to the left or right of 5? To the right. If it's x is less than negative 11, is that to the left or right of negative 11? Left. And there's my graph. I'm done with the problem. Any questions on number 4 here? You okay with that? We good? All right. Number 5 here. N plus 2 minus 3 is greater than or equal to negative 6. It's the very, very, very first thing I need to do. Yeah, make sure the absolute value is by itself. Is the absolute value by itself here? No. What number is with it? The 3. And what operation is going on between the absolute value and 3? What is it? Subtraction, right? What's the inverse of subtraction?
Addition.
Addition. So how do I get rid of that minus 3? Add 3 to both sides. So I get absolute value of n plus 2. Negative 6 plus 3 is? Negative 3. Symbol flip or stay? Stay. You only flip your inequality symbol if you multiply or divide both sides by a negative number. Okay? Is my absolute value now by itself? Yeah, it is. Nothing's going on outside the absolute value, is it?
No.
So it is by itself. Now what can I check?
The bar.
The C value. What is my C value? Negative 3. Is that greater than 0?
Yes.
No, it is not. It is not greater than 0. So can I set up my two inequalities here? No. So I need to check what the statement is saying and see what my answer is going to be here. Okay? It's saying that the absolute value of n plus 2 is greater than or equal to negative 3. What do we think our answer is here? And why?
It's no solution.
Why do you think it's no solution?
Because it's a negative.
Because it's negative? Think about what the statement is saying, though. The absolute value of n plus 2 is greater than or equal to negative 3. Why do you think it's all real numbers?
Because it's like, it says that it's less than. So if you multiply, like if you turn n into any real number, it's going to come out as a positive.
Very good. I agree with that. Any number I plug in for n here is going to either give me 0 on the left-hand side or some positive number due to those absolute value bars, right? Will 0 or any positive number always be greater than or equal to negative 3?
Yes.
Yes, it will. Always, without a doubt, right? It will never give me a negative number. So, it is all real numbers in this case. Does everyone understand why this is all real numbers? So just because it's a negative doesn't automatically mean that it's no solution, does it? Like I said, we've got to look at the statement that it's saying. If it's saying my absolute value is going to be greater than or equal to a negative number, that's always going to be true no matter what number I plug in. Okay? Can I graph all real numbers?
Yes.
Yeah, you can. How do I graph it?
The whole number.
It's the whole number line, right? So if they give you a number line, just shade all of it. If they tell you to graph it and they don't give you a number line, just draw one yourself with any numbers you want on it and just shade the whole thing. And that's it for number 5. Any questions on that? How do you feel about that one? Good? Can I erase and move to number 6?
Yeah.
I'm going to erase all of 4 and 5's work because I'm going to need a little bit more room for number 6. All right, number 6 is the absolute value by itself. Now, I've got a few things going on outside my absolute value, right? So it would be my first step to get it by itself. Someone raise your hand. Raise your hand if you can give me my first step here. Raise your hand. Yes. Not divide by 3. Not yet. Not subtract 7. Add 7, right? Before I can get the absolute value by itself, I need to get the term containing the absolute value by itself first. So I got to get rid of that minus 7. So I'm going to add 7 to both sides. Let's bring our work over here. So I get 3 times the absolute value of d plus 1. Negative 1 plus 7 gives me 6. Symbol flip or stay? Stay. We okay with that first step? Now what would I do with that 3?
Distribute.
Not distribute. I cannot distribute through an absolute value. Divide by 3. 3 is being multiplied by my absolute value. Inverse of multiplication is? Division. So if I divide by 3, cancels out. Whatever I do to one side, got to do to the other. So I get the absolute value of d plus 1. 6 divided by 3? 2. Symbol flip or stay? What?
I stay.
Stay. Very good. Questions on that step? Is my absolute value now by itself? Yes, it is. Since my absolute value is now by itself, what can I check now? The C value. What is my C value? 2. Is that greater than 0?
Yes.
Yeah, so what can I do now? Set up my 2 inequalities, right? So what does my first inequality look like?
D plus 1 greater than 2.
Very good. D plus 1 is greater than or equal to 2. Exactly the same without the bars. I don't know how many times I can say it, but I'm going to keep saying it. Exactly the same without the bars is my first inequality. Raise your hand if you can give me my second inequality.
D plus 1 is less than negative 2.
Less than or equal to negative 2. Very good. Exactly the same. Make the C value negative. Flip your inequality symbol. We good with those two? Raise your hand if you can tell me if it's and or.
Or.
Raise your hand.
Or.
How'd you get or?
Because it's less than or equal to. And so
Greater than or equal to.
oh yeah.
Yeah, greater than or equal to. The greater than is next to the O on goal, so I know it's going to be or. Now be careful here. We want to look at the inequality symbol when the absolute value is by itself. So I'm looking at this inequality symbol right here. Does that make sense? Sometimes, I don't want you to look up at the original problem. We want to look at the one when the absolute value is by itself. Because sometimes, I might multiply or divide both sides by a negative, and my symbol might flip. Does that make sense? So we want to look at it whenever the absolute value is by itself. So I'm looking at that inequality symbol right there. for my and or. Everyone okay with that? In our case, it didn't flip, so it stayed the same throughout. But like I said, sometimes it might flip, so you need to be aware of that. Okay? All right, now I can solve my compound inequality. What's my first step on both of these? Subtract 1 from both sides. So I get D on the left. 2 minus 1 gives me 1. Symbol, flip, or stay? Stay. You must have or in your answer. Once again, I get D on the left. Negative 2 minus 1? Negative 3. Symbol, flip, or stay? Stay. Are the D's now by themselves? Yes, they are. Question's how I got that solution. So my solution is any number that's greater than or equal to 1 or less than or equal to negative 3. Am I good to graph? Yeah, question. Say it again. Right here? That's a D. Sorry. Is that better? Ish. Okay. Let's graph. Open or close dot on 1? Closed. It's got that line underneath it. It's or equal to. Open or close dot on negative 3? Closed. Okay, D is greater than 1. Is that to the left or right of 1? Right. D is greater than 1. Or D is less than or equal to negative 3. Is that left or right of negative 3? Left. There's my graph. I'm done with the problem. Any questions on number 6? How are we feeling about absolute value inequalities? Pretty decent, hopefully? Yes, no, maybe so? Okay. We will get some practice here in a second. We'll also get some more practice tomorrow and possibly even Monday before we take our test sometime next week. Okay? Are there any questions about our notes that we took today? Can I move on to the assignment? Yes. No? Yes. Page 95. 2 through 18 evens. It's like 9 problems. It's not too terribly bad. Okay? This will be due Monday. That's the 10th on Canvas. Due Monday the 10th on Canvas. Are there any questions about my notes before I end the recording? All right.